we want to show that this telescoping series converges to 3. So for this infinite series, the sum of the first 10 terms will be when n is 1, we get 2 over 1. When n is 1, we get 2 over 3. So this is the first term. When n is 2, we get 2 over 2, and then 2 over 4. And when we get to the 10th term, that's when n is 10, then we get 2 over 10 and 2 over 12. And if we add all these together, we get 2.651515 and so on. The sum of the first 100 terms will be term number 1 plus term number 2 and then plus term 100, the 100th term. Add them together, we get 2.96059. Sum of the first 1,000 terms will be first term, second term, all the way up to the 1,000th terms. Add them up, we get 2.960059. Sum of the first 10,000 terms, this is term number 1, term number 2, and up to the 10,000th term. And we get 2.9996005. And then sum of the first 100,000 terms, we get, this is term number 1, number 2, and then up to the 100,000th term. And we get 2.99999. And we can see right here, this is 100,000 terms. And so as n gets larger and larger, we're just getting more 9s right here. And so as n gets larger and larger, the sequence of partial sums, this sequence right here, is approaching 3. And now let's do the analysis and show that we do get 3 for the sum. So let's write out the sum of the first k terms. So a sub 1, the first the sum of the first k terms, a sub 1, a sub 2, a sub 3, a sub 4, up to a sub k. And then the term before that is a sub k minus 1. Before that is a sub k minus 2. Before that is a sub k minus 3. So this is term number 1. That's when n is 1. So we get 2 over 1, 2 over 3. This is a sub 2. That's when n is 2. We get 2 over 2 and then 2 over 4. This is term number 3. Term number 4, term number 5, term number 6, number 7, number 8. And then when we get to the k minus 3 term, in the place of n, we put k minus 3 and k minus 3. And then for the k minus 2 term, in the place of n, put k minus 2, k minus 2. For the k minus 1 term, in the place of n, put k minus 1, k minus 1. And then when we get to the kth term in the place of n, put k and k. And then simplify a little bit. k minus 3 is k minus 3. K minus 3 plus 2 is k minus 1. K minus 2, k minus 2 plus 2 is just k. And then we have k minus 1. K minus 1 plus 2 is k plus 1. And then we have k and then k plus 2. And so for s sub k, this is what we have. But notice the following. This is minus 2/3 and this is plus 2/3. So this and that will cancel out. Minus 2/4 will cancel out with the 2/4. So that will drop out. Minus 2/6 will cancel out with plus 2/6. Minus 2/7 will cancel out with this 2/7, and then minus 2/5 will cancel out with 2/5. Minus 2/7 will cancel out with that. And eventually what's going to happen is all of these terms will get canceled out. And then we can see right here, minus 2 over k minus 1. This term will cancel out with that term. And then this is k minus 2. This is 2 over k minus 2. Eventually it will cancel out 2. Get canceled out, and then the 2 over k will cancel this out. So what's left is going to be 2 over 1, 2 over 2, minus 2 over k plus 2. And so that's what the sum of the first kth terms is. It's 2 plus 1 minus 2 over k plus 2. So we have the sum of the first kth terms to be 2 over 1, which is 2, 2 over 2, which is 1, minus 2 over k plus 2. And so the infinite series, which is the limit of s sub k, as k runs to infinity. But s sub k is 2 over 1, 2 over 2, minus 2 over k plus 2. So we get limit of 2, which is 2, limit of 1, which is 1. And then as k runs to infinity, this term 2 divided by infinity, which is 0. So we get 3. And as we saw earlier with the simulation program, we saw that as n gets larger and larger and larger, the sum is approaching 3.